In this video, we're going to go over Module 3, Topic 1, Lesson 1, Part 2. So we're doing more factoring. We're going to learn some new factoring techniques. So in a polynomial of 4 terms, you may notice that although not all the terms share a common factor, a pair of the terms may share a common factor. In this situation, you can factor by grouping. So our new method that we're going to use is factor by grouping. And this typically occurs when you have 4 terms. So factor the polynomial expression by using factor by grouping. So when we're factoring by grouping, what I believe is going to make it easier for us is if we kind of draw a line down the middle. And we're going to group the first 2 terms together and the second 2 terms together. When we are grouping them together, what we're going to look for in each set of terms is the greatest common factor. So with x cubed plus 3x squared, the greatest common factor is an x squared. So we're going to factor that out. So remember, when you factor it out, you're essentially dividing by x squared. And then what's left over will go inside the parentheses. So 3x cubed divided by, x cubed divided by x squared is x. 3x squared divided by x squared is 3. Then you look on the other side, and you're going to repeat this process looking for the greatest common factor with this. Now, this is going to be a -1. Typically, it will be a -1 or a negative number when this term is negative. So we're going to divide out a -1. And so that gives us -1. And then what's left over, -x divided by -1 is x. -3 divided by -1 is a +3. So now what we have here is our polynomial term. Let me scoot this over. Okay, and it's been factored. Notice that within this, there is another greatest common factor where both sides have an x plus 3. So that is going to be our greatest common factor for the third time. Now it's x plus 3. So essentially, we're just going to divide this by x plus 3, divide this by x plus 3. And so remember, our GCF goes out in front. And then what's left over will go in the parentheses. Well, what's left over is the x squared and then the -1. Now, be careful because sometimes at this step you will be done and sometimes you won't. So in this case, we're not going to be done because this right here is a difference of squares. So remember, for a difference of squares, you can take the square root of the first term. So the square root of x squared is x. You can take the square root of the last term. The square root of 1 is 1. And so when you factor it, you're going to have 2 sets of parentheses. The first term goes in the first spot. The square root of the second term goes in the second spot. 1 plus, 1 minus. And then the last thing, we're just going to drop down that x plus 3. And so now we have this completely factored. Okay, so it's a new step. And again, it's just a lot of greatest common factor stuff. Okay, so now we want to use the factor by grouping method to factor and identify the zeros. So now once we get it factored, we're going to solve for x, which we did not do on the first one because it didn't say to find the zeros. So here we go. We're going to draw a line down the middle. We're going to look for the greatest common factor in the first 2 sets of terms. So that's going to be an x squared. So we're dividing out an x squared for both terms. So remember, the GCF goes on the outside. And then what's left over? X cubed divided by x squared is x. 7x squared divided by x squared is 7. Looking on our other side, we're going to find the GCF. So it looks like they're both divisible by a -4. So we're going to divide out a -4 from both sides. And so the GCF goes on the outside. What's left over will go inside the parentheses. So negative 4x divided by negative 4 is just an x, and negative 28 divided by negative 4 is a positive 7. Now, something I did not say in the last one is that you know you're doing this correctly when you get to this step and there's a greatest common factor inside the parentheses. It happened in the previous problem as well. Once we got to this step, we had a greatest common factor. That is your way of kind of self-checking as you go through this process. So this right here has x plus 7. This right here has x plus 7. So that means that there is a greatest common factor of x plus 7. So we're essentially just going to divide that out so we can finish our factoring. So remember, our GCF goes out first, and then what's left over would be x squared minus 4. And just like before, we have to double check, can this be factored more? And yes, this can. This is another difference of squares. I'm going to abbreviate difference. So we have the square root of x squared. We should be professionals at that by now. That's x. And the square root of 4 is 2. So we factor this as x and x. 2 and 2, 1 plus, 1 minus, and then x plus 7. So this is going to be set equal to 0, so we can solve for our x-intercepts. And so we have x plus 7 equals 0, x plus 2 equals 0, x minus 2 equals 0. So we solve the first equation by subtracting 7. We get x is equal to a negative 7. We subtract negative 2 from the second equation, or we subtract 2, and we get x is equal to a negative 2. And on the third equation, we add 2, so we get x is equal to a positive 2. These right here are the zeros, the x-intercepts, the roots, the solutions. And again, how do you know how many zeros you should have? Remember, that's based on the degree. So the degree in the very beginning was 3, which means you can have at most 3 zeros, and that's exactly what we have. Okay? Now, some degree 4 polynomials are written in a trinomial form. They have the same structure as quadratics. When this is the case, the polynomial may be factored using the same methods you would factor a quadratic. This is called factoring by using quadratic form. So we've done a problem like this before. We just factor it like normal. So the first thing you ask yourself, is there a greatest common factor? And the answer is no, there is not one. Okay, then we look, do we need to do slide and divide? Does our leading term have a number other than 1 in front? No. So we go straight into our process of factoring. So 100 goes on top. Negative 29 goes on bottom. So we want to multiply to get 100, add to get 29. So let's see, what can we multiply to get 100? If you're unsure in your calculator, you can do 100 divided by x and then pull up the table by hitting Control T. Or if you're in Desmos, pull up the table that way, whichever one you prefer. So to multiply and get 100, we can do 1 times 100. We can do 2 times 50. 3 does not go into it evenly. 4 and 25. 5 and 20. And then the last one would be 10 and 10. So which combination of these could we get 29 or negative 29? It would be 4 and 25, but they do both need to be negative. So we have a negative 4 and a negative 29. Now, when we go to factor this, okay, we have our 2 sets of parentheses. Now we need to think about what can we multiply to get x to the 4th? Well, that's going to be an x squared times an x squared. So then from here, we have minus, oh, and I just realized that should have been a 25. So we have minus 4 and minus 25. Now, for both of these are both a difference of squares. So we've already factored x squared minus 4 in the previous problem. So we know that this should factor into x minus 2 or x plus 2 times x minus 2. It does not matter which one goes first. The second one we haven't done, but we do know that it's going to be x and x. Now we just need to think about the square root of 25, and we know that to be 5. So we have a plus 5 and a minus 5. And so this would be completely factored. If you needed to solve, you would set them equal to 0 if you needed the zeros or x-intercepts root solutions. But this one just said factor. Okay, so we can't forget our difference of squares in making sure that we factor completely. Now, if it was x squared plus 4, then we couldn't factor that and we would leave it like that. But if it's a difference of squares, we got to make sure we keep going. Okay, so why don't you pause the video and try to factor each polynomial over the set of complex numbers and then use the factors to identify their zeros. Okay, so hopefully you gave this a shot. So on this first one, notice we have 4 terms, but before we even try to do factor by grouping, let's factor out the GCF of x because each term has an x. So let's factor that out. Let me change my colors so I can be consistent with my colors. Okay. So we're going to divide each thing by x, and all that does is makes the numbers just a little bit smaller for us to work with. If you forgot to do this, you could catch this in a later step. So I have x, and then we would be left with x to the third minus 4x to the second minus x squared plus 4. So now that we've done that, we can go ahead and do our factor by grouping. And so we need to make sure when we do this, we are going to basically ignore this until the end. It's just going to keep tagging along and tagging along. So in my first 2 terms, notice that the GCF is an x squared. So we're going to factor out an x squared here, factor out an x squared here. So that would be x squared. What is left over? That would be an x minus 4. On the other side, GCF, it looks like it is just a negative 1. And I realized that I did not take that off whenever I divided out an x. So I'm dividing out a negative 1. When I do that, I'm left with x minus 4. And then I'm going to put big brackets on it, and I'm going to bring down that original GCF. Now, when I'm looking at this, I notice that they both have an x minus 4 in common. So we can factor that out. X minus 4, x minus 4. So we have that original GCF. Then we have the x minus 4. And then we have x squared minus 1. Now, x squared minus 1 is a difference of squares, so we can keep factoring. So, difference of squares, we have 2 sets of parentheses. Square root of x squared is x, and x. Square root of 1 is 1 and 1. 1 plus, 1 minus. So now we have it completely factored. So this right here is completely factored. Okay? But we want to solve for the zeros. So remember, we set everything that has an x equal to 0 so we can solve. First one, you don't need to do anything for. Second one, we need to add 4 to both sides. Third one, we need to subtract 1 from both sides. And the last one, we need to add 1 on both sides. So our zeros are x equals 0, 4, negative 1, and 1. That is where our graph is crossing the x-axis, and we have 4 zeros. Hopefully that's what you were expecting because we started with a degree of 4 polynomial, which means we can have at most 4 zeros. Okay, looking at the last one, Okay, this is the one that is like the quadratic form. So first thing we ask ourselves, is there a greatest common factor? And the answer is none. Okay, then we look, is there a number in front of our x to the fourth? And that's a no, so we don't have to do slide and divide. So we can go straight into our process. So we want 9 on top, negative 10 on bottom. So we want to multiply to get a negative, or to get positive 9, but we want to add to get a negative 10. So if we're multiplying to get 9, we could do 9 divided by x, pull up the table. That would be 1 and 9, 3 and 3. So the only combination that could get us a negative 10 is if we take these two right here and turn them both into a negative. So we have a negative 1 and a negative 9. So we factor this out. We have x squared times x squared. That gives us x to the fourth. Then we have negative 1 and negative 9. Now both of these are difference of squares. I believe we have already factored x squared minus 1. So that would be just x plus 1 times x minus 1. Now, I don't think we factored the square root, or x squared minus 9, but we know the square root of 9 is 3. So we have x and x, 3 and 3, so 1 plus, 1 minus. Okay, we set this equal to 0, and then we can solve for the x-intercepts. Now, this is completely factored, okay, but we want to solve for the zeros. So now we take each factor and set it equal to 0. So the first equation, we subtract 1 from both sides. We get x equals negative 1. Second equation, we add 1 to both sides, so we get x is equal to 1. Third equation, we subtract 1 from both sides. We get x is equal to a negative 3. And last equation, we add 3 to both sides, and we get x is equal to a positive 3. So these would be our zeros. X equals negative 1, positive 1, negative 3, and positive 3. So if you have any questions, please make sure you write them down, and don't forget to answer your essential questions.